If you're sitting the Cambridge IGCSE Physics 0625 exam, you are operating in a system where precision isn't just encouraged, it is ruthlessly demanded by the marking scheme. So we're jumping straight into the high mark exam strategy that actually separates average students from top band achievers. 15. I want you to take a second and really think about that number. 15 marks. In the Cambridge grading system, 15 marks is the exact number standing between your current grade and your absolute target grade. Literally an entire grade boundary. And here's the truly frustrating part. You're rarely losing those 15 marks because you didn't understand the complex physics concepts. No, you're losing them due to simple, entirely preventable math errors. So, I have to ask you a really high-stakes question right out of the gate here. Are you quietly bleeding marks on missing units and early rounding? Seriously, think about your last mock exam. Picture it. You're sitting in the exam hall, the clock is ticking, the timing pressure is immense, right? You calculate the final answer, you write down the number, and you quickly move on. But you forgot the unit. Or maybe you rounded the number halfway through the calculation instead of waiting for the very end. Instantly, you drop a grade boundary, mark by agonizing mark, without even realizing it. Now, you might be thinking, look, I've spent hours on flashcards, I know literally every formula in the syllabus. But memorizing formulas is absolutely not enough. And this is exactly why ordinary revision fails so many hardworking students. Simply knowing that force equals mass times acceleration, that is not going to save you from strict Cambridge examiner traps. They aren't just testing your memory, they are testing your mathematical discipline. And this official math skills grid, derived straight from the syllabus, brilliantly illustrates exactly what I mean. It reveals the massive scope of what's actually expected of you. Chapter 1 alone demands that you master choosing the correct units, determining significant figures, and converting numbers to and from standard form. Chapter 3, that requires you to choose the best access scales for accuracy when drawing graphs. This whole thing isn't just about plugging numbers into a calculator, it's about processing data with complete scientific literacy. So based on the syllabus data, this all builds into 3 incredibly painful learner mistakes that cost vital method marks right out of the gate. First up, missing units. Look, a number without a unit is completely meaningless in physics. Second, rounding too early, which just cascades into massive inaccuracies in your final answer. And third, graph axis errors, like choosing some awkward scale that makes plotting anomalous data practically impossible. If you're making any of these errors, your hard work is honestly going to waste. But, in a moment, I'll show you the exact examiner clue that changes the answer completely. It's a specific shift in how you read the question that practically hands you the missing marks. You absolutely cannot afford to miss this. But first, you need the framework that makes that exact clue glaringly obvious to you in the middle of a stressful exam. We really have to rebuild how you structure your answers from the ground up. Okay, so here is the definitive 4-step answer framework used to secure those top band marks in Cambridge IGCSE Physics. Step 1 is the concept. State the key definition, law, or equation. Step 2 is evidence and data. Substitute your values using the source page evidence. Step 3 is scientific reasoning. Explain the actual physical mechanism at play. And step 4 is examiner wording. Now listen closely because it is this 4th step that trips up 80% of students. Let's define exactly what that final step means in the context of our math skills. Examiner wording isn't just about writing neatly. It means fulfilling the specific command words by using exact terminology, calculating to the correct significant figures, which usually means matching the least precise piece of data given to you, and applying proper unit prefixes. Back in step 2, substituting evidence requires total fluency. If your variable is extremely small, you must instantly translate that into standard form, like times 10 to the negative 3, and recognize the milli prefix. This kind of fluency is what actually secures the method mark. Okay, the stakes are high. It's challenge time, spot the error. I want you to step into the role of the Cambridge examiner right now. Imagine you are holding the red pen and you have to grade the following student response. Try to apply the framework we just discussed. Here is the student's answer. They wrote, the current is 0.025, and the resistance is big. Just let that sink in for a second. Read it over again in your head. The current is 0.025, and the resistance is big. I want you to pause and predict for a second. Where are the missing method marks here? Look at that number. 0.025 what? Apples? Cars? The units are completely missing. And look at the reasoning. The resistance is big. Big is a vague, unscientific word that shows absolutely zero command of exact physics terminology. So, the crucial point here is seeing exactly how a top student corrects this. Let's compare the two. The flawed answer says 0.025 and big. The top-hand answer perfectly utilizes the framework. It says 2.5 times 10 to the negative 2 amperes. See what they did? They converted that awkward decimal into a clean standard form. And most importantly, they included the unit A for amperes. This fulfills the evidence step and the examiner wording step flawlessly. If you had submitted that flawed answer, here is the harsh reality of the examiner feedback you would receive. Final method mark withheld for incorrect unit prefix and early rounding. Think about the psychological impact of that for a minute. You understood Ohm's law. You knew the physics, but you lost the final mark because of a poor math habit. That is exactly how grade boundaries slip away. Now, what's really interesting is what happens next. Let's say you take all of this to heart, right? You fix your unit prefixes, you master standard form, you stop rounding early, you've totally mastered the math, but actually fixing these math skills has just exposed a brand new, highly critical vulnerability in your exam strategy. Because here's the thing, calculating the correct number is totally useless if you cannot evaluate the practical investigation data in the follow-up questions. This is your unresolved problem. In paper 4 or paper 6, calculating the gradient of a graph is only half the battle. If you lack the top-band evaluation framework to explain why that data is reliable, or how to identify an anomaly, or how to suggest a valid practical improvement, you are still going to hit a massive glass ceiling on your grades. The missing piece of your overall strategy is only in the next explainer. Now that your numbers are accurate, learning the evaluation framework is your mandatory, urgent next step to cross that final grade boundary and secure your target grade. You simply cannot stop here. To make sure you don't miss out on securing those final marks, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Go ahead and click the progress arrow on screen to seamlessly transition into mastering the evaluation framework. But before you go, ask yourself, if your mathematical calculations are flawless, but they are based on fundamentally unreliable experimental data, did you really solve the physics problem at all? I'll see you in the next explainer.